All right, so what we're going to do here is I'm going to introduce to you the gravity drop experiment from CPO Science, formerly Cambridge Physics Outlet, and how we're collecting data in the labs that we're going to run with this apparatus. So to start off with, the apparatus up here includes another version of what I have in my hand, which is the CPO timer with photogates. And I will bring that a little closer so you can get a better view of it. So this timing device here operates these photogates, and as you may expect from the name, the photogate is a light gate, and so there are behind these seams here, there is an LED, an infrared LED, and a sensor on the other side, and I'm not sure which one's which just by inspection, but they operate in a way similar to how a remote control device might work for a television set or stereo receiver and so forth. So they are, once you turn on the device, those LEDs are on continually, and so the sensors can let us know when they're not receiving signal anymore. So when the beam has been broken, when some object passes by. The mode that we're going to use for this apparatus down here below is the interval mode, which you can see indicated by the little yellow, is it yellow or green? Green LED down below. And what that means is this. Let's say we have some object pass, blue is plugged into gate A here, the red cable is plugged into gate B. We have some object pass through both gates in succession, first gate A and then gate B, like my hand here. It will record a time. It will record actually 3 times. When both lights are lit, ooh, do we trigger it again? All right, so let's start this over. You can reset to clear. Okay, so what you get with this are a single time when both lights are lit, which indicates the amount of time it took to go first through one and then through the other. And then when you have only the A light lit, that's not right. Let's try this again. Yeah. When we have only the A light lit, it tells us the time that the A light was blocked. When we have only the B light lit, it tells us the time that the B gate was blocked. So we get to use these with our gravity drop lab, like so. The lab includes a dropper for dropping either a steel ball bearing or a plastic ball. The CPO instruction manuals refers to these as marbles, but ball bearing. And they're like so. This is about 1.9 centimeters diameter. And it's suspended in this clothespin-like device and then dropped down into a catcher. You can place the catcher up higher, but I prefer to move as few items as possible over the course of the experiment. And since we're going to be moving the photogate down, I'm going to leave the catcher down at the bottom. Now, many of these stands have built into them a little level bubble, which you can use to help make sure that everything is plumb and whatnot. We have a plumb bob itself here, which has a little cylinder to grip it. And we can use that, steady it a little bit, as another check on our true vertical. And this is important not just so that it gets caught, but because if we're out of vertical, the ball is going to pass through the gates, not along its full diameter. We care about that because its diameter is intended to be the distance it travels while blocking one of the photogate lights. We can use that distance traveled divided by the time we record from the timer to determine the average speed while blocking that gate. Do the same thing with the second gate. So we have two different speeds. And in this way, as we move our second gate down, we can see a relationship between that distance and the speed and how it will change with time. But we can also, with the two lights lit, get the time in between the two gates, and therefore we can also get data telling us how that speed at the bottom gate changes with time, in addition to with distance. We know also that the average acceleration is going to be the change in velocity divided by the time it took to do that change. So once we've determined the two speeds, it's also possible to determine the acceleration or the average acceleration across whatever time interval it took to go from one to the other. Time with both lights lit in the denominator there. So that's the basic operation, and in practice what this looks like here, if I turn this on, is like so. And we, I got all three times here, which we can toggle between, and which I'll do before I record anything else. It has all three times, so I don't need to do three separate runs to collect additional data. And things to make note of while we're doing this: we can reduce our error if we make every effort to not shake the device back and forth while we're launching it. So you can get additional control if you're not reaching up high above your head to operate it. So if you stand up on a chair or lower the entire apparatus down, you may get additional levels of control that way. So we can work it however. And that's basically it.